Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help demonstrate for you how to calculate what's called a center of mass. So before we talk about center of mass, I want to talk a little bit about how your grade point is calculated if you're taking some classes. So that's what we're going to chat about over here. So let's imagine that you're taking, physics, which is typically something like 5 credit hours, and you're taking an English class, which is 3 credit hours, and a math class, which is 4 credit hours, and you get the following grades. In physics, you get a 3.0, and in English, you get a 4 point, and in math, a 3.5. So we've, had a pretty good semester there. Now, when somebody asks you, what is your average grade? Well, what you can't do is just take these numbers, add them up, and divide by 3. And the reason is because physics, for example, is more credit hours than English. So what that means basically, as far as your grade is concerned, it's worth more, if you will. It has a higher weight. So when you calculate your grade point, you have to take into account how many credit hours each course is worth. So your grade point is calculated by taking what's called a weighted average. What you're averaging are these numbers, but you're assigning a weight to each number via the number of credit hours. So when you calculate your grade point, it would look like this. We take our grade in physics, which is a 3 point, and then we multiply by the number of credit hours. That's what gives it a weight, if you will. Then we take our grade in English. Oops, I guess I wrote those backwards, no, I didn't, I'm sorry. The grade in English is a 4 point, and then we multiply by the number of credit hours. And then again, 3.5 in math, multiplied by the number of credit hours. So the top of this fraction effectively has units of grade times credit hours. Then what we do is divide out the total number of credit hours, which in this case, hopefully I did the math right, would be 12 credit hours. If you do the math on that, your average grade point comes out to be 3.42 for the semester. We had a good semester there. All right, so let me get rid of this now. We don't need it anymore. All right, so the center of mass of a system of masses is found the same way. The center of mass of this system is probably, looking for my pen there, is probably something like in a location, something like about here. I'm just kind of guesstimating about where it's at. And what the center of mass is, the context of it, well, if this were like a rigid object, you could balance it about this point. That would give you kind of a rough estimation of what the center of mass is. And what it's typically used for in physics is it's usually the location where you put the weight vector in a free body diagram. Now, I said usually. Technically, you put the force vector for the weight at what's called the center of gravity. But in a uniform gravitational field at the surface of the Earth, the center of gravity and the center of mass are at the same locations. So let's go about finding it. Now, this is a two-dimensional example. So the center of mass of the system has an x-coordinate to it, and it has a y-coordinate to it. And we typically put these bars over these values because a variable with a bar over it means average. So we're looking for the average x-coordinate and the average y-coordinate. And each of these masses in this example is at a set of coordinates. So like this one is at the coordinate 0, 0. This one is at the coordinate, can't really see that, 0, 50 centimeters. This one is at the coordinate 60 centimeters, 50 centimeters, right? So what we're going to do to find x bar is we're going to average the x coordinates, and we're going to assign a weight to those averages using the mass. So the first one, this one right here, the x coordinate is 0. And then we would multiply by 3 kilograms. Now, I didn't put the units on there, but keep in mind that would be 0 centimeters. Okay, the next one, let's talk about this one. So the x coordinate there again is 0. And again, then we would multiply by the mass. That's what gives it a weight, if you will. And then we're going to take the third one, which the x coordinate is 60 centimeters. and then we're going to multiply by the mass, 4 kilograms. And then what we do is we divide out the total mass of the system, which is, let's see, 4, 2, and 3 added together, they add to 9 kilograms. Now, notice that each term, in fact, we'll look over here because I didn't put the units on the zeros. You take kilogram, divide by kilogram, they divide out and you're left with centimeters. And that's true of every mathematical term here. So if I've done this correctly, I'm going to move this down. We should get 26.7 centimeters for the center of mass. I worked it out before I made the video here. So this should equal 26.7 centimeters. I'll leave that as an exercise to the viewer there to double check that. All right, y bar. Now what we're going to do is we're going to average all of the y coordinates. All right, so we'll take this guy. Its y coordinate is 0. And then we'll multiply by the mass to give it a weight, 3 kilograms. Then we take this guy, whose y coordinate is 50 centimeters. And then we multiply by the mass, 2 kilograms. Then we take this guy, which is 4 kilograms, and the y coordinate is 50 centimeters. And I need to make myself a little room here. And then we'll multiply by the mass. Let's see, which was 4 kilograms. I see I used a little bit different notation in the top line than I did in the bottom. In each case, you know, it's 0 times 3, 50 times 2, 50 times 4, etc. Whether I put the parentheses or multiplications between them doesn't really matter for the example. And then again, we divide by the total mass of the system, which is 9 kilograms. And again, very important to realize that each term, the kilograms are canceling every term, and we're left with centimeters. Now, if we work this one out, I think I got 33.3 centimeters. All right, and some important things, let's talk units. So can we work these in centimeters or do they have to be in meters? That's a question I could see somebody asking. And the answer to that is we can work them in any units we want because we're taking a distance and multiplying by a mass for every term, and then we're dividing the mass out. So whatever units we put the distance in, we're going to get our answer in those distance units. If I wanted to, you know, I could put inches in these locations and kilograms here, and then my x bar and y bar will come out to inches. So you can use any units you want. In the example that I've ran, all the coordinates were either 0 or some positive number. But, you know, if we added a mass, say, down here somewhere, you know, it's when we average its y coordinate, that would be just some negative value. That's the only thing that can vary a little bit. And that's pretty well it. That's how you calculate a center of mass. And, you know, what would we use that for? Again, probably the primary purpose is that if you put a single gravitational force vector for these 3 masses, this is where it would go. It would go at the coordinates 26.7 centimeters, 33.3 centimeters to represent the entire system. So anyway, purpose of the video is to help you understand how to calculate a center of mass. Hopefully this has done that for you. Have a great day.